Welcome back to the class again. My name is still Bamishebi Samson, and I'm the one taking this course, this assembly language. But we are now moving to course unit 2 of section 2. The objective of the course still remains the same thing. Then the study section still remains the same thing. But the learning outcome of this course unit, it is expected of students to be able to, at least at the end of it, should be able to do what? To state the element of assembly language and to also explain the syntax of assembly language statement. Because this section is saying, this section is talking about element of assembly language statements, which comprises composition of assembly language program, type of assembly language statement, syntax of assembly language statements, before it now takes us to the conclusion and everything. So, when we talk about element of assembly language statement, what do we mean by that? This is simply means assembly language is basically like any other languages, which means it has its words, rules, and syntax. That is, there are particular mode of words that is meant for assembly language, rules that is meant for assembly language, then the syntax of assembly language. Assembly language is a machine-dependent language and a low-level programming language. That is, without a machine, assembly language cannot exist. You understand what I'm saying? It cannot exist because assembly language is the one that interacts with the machine language directly. So it depends on the machine. So the precedence, look at it. Expression in parentheses, then unary plus and what are minus, then mode multiply, divide, modulus, and add, then subtract. Then that takes us to real numbers, real number constants. There are two types of real numbers constant. Decimal reals, which contain a sign followed by a number with decimal fraction and an exponent, sign integers. Then integer and exponents. Example is 2 plus 3.0, then minus 4.4.2e plus 0.5. Then we have 26e dot e5 encoded, which are represented exactly as they are stored. Character constant. A character constant is a single character enclosed in a single or double quotation mark. The assembler converts it to the equivalent value in the binary code, ASCII. So, string constants. A string constant is a string of characters enclosed in a single or double quotation mark. That is the example you see here, down here. Like A, B, C, then X, then you see good night, grace, double colon, you know, and then we'll give you the example of, this is, you can see, variable, one, open file, main, then look at the numbers, look at, these are examples of what? example of identifier. So now let's pick directives. Directives are command for the assemblers. I've said it in the previous class that they are what, and they are not necessary to participate in the main core operation of that program. They are just like a rule setter for assembler, telling it how to assemble the program. Do you get it now? Directives are command for the assembler, telling it how to assemble program. It is the one that will dish out instruction for the assembler on how to do the computation of its operation. So directives have a syntax similar to assembly language, but do not correspond to interprocessor instructions. Directives are also case sensitive. Example, .data, .code, or name proc. So instructions. An instruction in assembly language consists of a name or label, an instruction mnemonic operand, and a comment. The general form is name, mnemonic operand, comment. Statements are free from, that is, they can be written in any column with any number of space between in each operand, as long as they are on one line and do not pass column 128. So label. Labels are identifiers that serve as place maker within the program for either code or data. That is, they are the one who provide platform for either data or code. They are replaced in the machine language version of the program with numeric address. We use them because they are more readable. Move AX 90 in bracket and bracket, then versus move AS my variable. Code labels. Code labels mark a particular point within the program code, whereby code labels appear at the beginning and are immediately followed by column target. Move AX or BS blah blah till jump target. Data label. Data label that appear in the operand field of an instruction. Move first. AX.data label must first be declared in the data section of the program. First byte 10. So instruction mnemonic. When we say instruction mnemonic, instruction mnemonic are abbreviations that identify the operation carried out by what? By the instruction. For example, move hello move equals to move a value to another word, to another location. That is what, if you see move, that's what you are moving from one location to another. Then add, it is either you are adding two values together. Sub means subtract a value from another. Jump to a new location in the program. Then why mod, it means multiply two numbers, two variables. Then call is mean to call for a procedure. Then operands. Operands in an assembly language instruction can be constants, 96, constant expression 2 plus 4, register EAX, then memory location count. So operands and instruction, we have to operand and instruction. All instructions have a predetermined number of operands. Some instructions use no operands. STC then semicolon sets the carry flag. Some instructions use one operand, like ink AX semicolon add 1 to AS cap. Some instructions use two operands. Are you with me? Move count BS semicolon add BS to count. So this takes us to comments. Comments serve as a way of programmers to document their programs. I've said it in the earlier class. Comments can be specified on a single line, beginning with semicolon until the end of the line. ST semicolon sets the carry flag. You understand what I'm saying? Then in a block beginning with the directives, comment and a user specified symbol which also ends the comment. That takes us to type of assembly language and statements. Assembly language programs consist of three types of statements: executable instruction or instructions, assembler directives or pseudo operation or micros. The executable instructions simply instruction tells the processor what to do. Each instruction consists of an operation code or OP code. You can write it like that. Each executable instruction generates one machine language instruction. I hope you understand what we are trying to say in that place. They were trying to tell you directly that for every executable instruction, it gives command to processor on what to do. And each instruction always contains OE code, which is operation code, that are executable instruction generate one machine language instructions. The assembler directives or pseudo-O tell the assembler about the various aspects of the assembly process. These are non-executable and do not generate machine language instruction. Micros are basically a test substitution mechanism, so that you will be familiar with what we are trying to do there. So that takes us to syntax of assembly language. Syntax of assembly language. Assembly language statements are enter one statement per line. Each statement follows the following formats: label, mnemonic, operands, and what? Comments. So now, The field in the square brackets are optional. A basic instruction has two parts. The first one is the name of the instructions or the mnemonic, which is to be executed, and the second are the operands or the parameters of the command. Following are some of the examples of typical assembly language statements. Ink count, increment the memory variable count. Move total, 48, transfer the value 48 in the memory variable to variable total. Add AH, BH, add the content of the BH register into the what? AH register, and mask 128 perform and operation on the variable marks 1 and 128. Then add marks 10, add 10 to the what? To the marks. Then move AL, 10. Then transfer the value of 10 to the AL register. I hope you understand how this syntax, these are rules that a programmer who is programming in assembly language must make use of. That these are guiding rules to write a correct programming code in assembly language. So with this, I think we have come to the conclusion of this particular class. You have been able to at least add the rudiment of assembly language statements. And at the same time, you have, I believe that you have been able to learn the basic syntax of assembly language statement and the difference between assembly language statement also. So you have to also pick up the material so that you can at least broaden your knowledge on this assembly language. So you look outside this perimeter so that you consult some other books so that you can at least, and you see some practical so that you can practically at least widen your scope of understanding of assembly language. Thank you for listening, and you are welcome again.